There's good news as we start to graph logarithmic functions. We're not going to be real particular about how we do them. Since we're not going to be terribly careful about it, instead of saying the word graph, let's say we're sketching these logarithmic functions. To be able to do that, regardless of what the base is for the log, there are three things we'll need to do. The first thing is to find the domain of the log. That's right, this is the next thing that has a domain restriction. We can only take the log of things that are positive. I cannot take a log of something negative, and I cannot take a log of 0, so the value we're taking the log of must be positive. To find our domain, we'll take whatever stuff is in parentheses, make it greater than 0. The second step, we'll have vertical asymptotes for these logarithmic functions. They will occur at the boundary of that domain. So to find where the vertical asymptote is going to be, let's take the stuff in parentheses and set it equal to 0. This will be our vertical asymptote, and its x equals a number since it's vertical. The last thing is to figure out an X Intercept. There might be a little bit of a surprise here. In order to do the X Intercept, take the stuff in the parentheses, set it equal to 1. This has to do with rules for exponents that we'll talk about in class, but to do an X Intercept, take the stuff in parentheses, set it equal to 1. Let's see it in action. For this one, finding the graph for the log of x minus 1. There's no base written here, so it's understood to be a base 10 or common log, but that doesn't matter for our graphing. The first thing we'll do is find the domain by taking the stuff in the parentheses, making it greater than 0, and solving. As we move that 1 across by adding, I end up with x greater than 1, and the domain then is from 1 to infinity. Notice my parentheses, it's strictly greater than, so the 1 is not included. The vertical asymptote comes from taking the stuff in the parentheses, set equal to 0. In this case, x minus 1, when you set it equal to 0, gives you x equals 1. On my picture, I've identified that with the vertical dotted red line. And our final step is to find the x-intercept, taking the stuff in the parentheses, setting it equal to 1, and solving. If I add 1 to both sides, looks like my x-intercept is at 2. Remember, this means 2, 0, because the y value of an x-intercept is always 0. I've located that in green. Now, the shape of anything logarithmic, the way they will look every time, they are very steep when they're close to the vertical asymptote, and then they flatten out after they hit the x-intercept. So the shape that we'll have will look very much like this every time. It'll be steep when it's close to the vertical. It'll hit the x-intercept, flatten out from there, but it does continue to increase forever. So now the domain we said was restricted, the stuff in parentheses greater than 0. The range of this though, the lowest y, there's not 1, it's going forever down. The highest y, it's going forever up. It's increasing slowly, but it does go forever up. So the range is from negative infinity to positive infinity. Let's look at a few more examples. Here, we won't try to graph it. We'll just find each of the parts that would allow us to. For the domain of the log of x plus 2, take the stuff in the parentheses, make it greater than 0, solve it from there, and looks like for this one, negative 2 to infinity would be our domain. I put parentheses with the negative 2 because that value is not included. The vertical asymptote is the stuff in parentheses set equal to 0. So this one gets a vertical asymptote at x equals negative 2. Vertical asymptotes are x equals a number. Then the last thing, the x-intercept, take the stuff in parentheses, set it equal to 1, and solve from there. Subtracting 2 from both sides gives me -1, so the x-intercept is at -1, 0. Notice that the x-intercept is always one place away from the vertical asymptote. This happens every time. Now, the last thing you might be asked to do is to translate these pictures, just like we've done in the past. Putting a constant at the back will move the picture up or down. Putting a constant in the parentheses will move you left or right. So now as we look at this one, let's take a base 3 log of x and move it right by 1 and up by 2. If it's a base 3 log of x that we're trying to translate, then I need to start with a base 3 log of x in my equation. Now to make it move to the right, you're going to need some parentheses. Remember, moving to the right is opposite of what you might think. So to move to the right by 1, I'll need a -1 in the parentheses. Negative signs move us to the right. Now to make it move up, on the outside, let's put a +2. Something on the outside makes a vertical shift, either up or down. Something on the inside moves you left or right. A negative moves you right, so a positive would move you left.